Welcome, fellow chemists. Today's video will cover the activity series and its use in predicting the outcome of single replacement reactions. I'm going to make two versions of this video. This one will be for those who do not have a strong grasp on writing chemical formulas for ionic compounds. If you know how to write chemical formulas, then a link will pop up now to the more advanced version after it has been posted. Let's quickly review what a single replacement reaction looks like. The setup is simple. A single element and a compound react to produce a new single element and a new compound. Notice how the single element, represented by letter A, is sitting at the front of the new compound as it replaced the letter B, which used to be at the front. In other single replacement reactions, the single element replaces the element at the end of the formula instead. Remember this for later. Those notes in the bottom corner were also helpful if you saw them. There are actually two activity series, one for the metals and one for the halogens. Though distinct, they are used the same way with the more reactive elements to the left. The incomplete metals list contains 16 elements, which is a perfect number for a mini tournament. Unlike actual tournaments though, every single matchup and indeed the entire outcome is already known. What do I mean? Simple. The more reactive element always wins. There are no upsets in the tournament of element reactivities. Lithium was not only destined to win, it was rigged from the start. Now let's look at how to apply this idea with an actual equation. In my video on reaction types, this example shows up with three possible outcomes. Option 1 shows the result of magnesium and aluminum switching places. The second indicates no reaction occurs, and the last has magnesium and chlorine switching. You may know which is correct, but one of them is automatically wrong. Why? Because the wrong elements switch. If a reaction occurs, it is because magnesium is more reactive than another element from the same list. This means magnesium can't replace chlorine because they are on different lists. So option 3 is incorrect. If you don't like that wording, simply rephrase it as don't pair elements on the same list. Now, according to the rankings, magnesium is the 6th most reactive metal and aluminum the 7th. Now ask the simpler question, does 6 beat 7? Yes! This means a reaction occurs and we now know the outcome. When the single element reacting is a halogen though, nothing really changes, so what happens in this reaction? Option 1 shows what happens when bromine and calcium switch places, the second indicates no reaction occurs, and the last has bromine and iodine switching. Identifying the fraud from the option still requires finding the one which pairs up two elements from the same list. This means option 1 is incorrect as it pairs the two halogens. So what happens? Well, looking at the ranking, bromine is 3rd and iodine is 4th. Does 3 beat 4? Absolutely. So we now know the outcome to this reaction as well. At this level, there isn't much more to the activity series. A basic understanding requires remembering three simple rules. First, the list of elements are ranked from most reactive to least. Second, the more reactive element always wins. This sometimes results in no reaction occurring. Finally, elements on the same list switch places with each other, so never pair them together. Practice questions where you can apply those rules will come up soon, but before you get to it, thank you very much for watching. While you work away in the basic activity series questions, I will get to work on the more advanced version where you have to write out the products from scratch. Good luck, and if you have any questions, leave a comment below.